It's 20,000 years ago. You're walking north, further from the equator than any human before you, and your body is quietly panicking. Not from the cold, from the sun, or rather the lack of it. Something inside you is starving, slowly, invisibly, and it has nothing to do with food. This is the story of how sunlight rewrote the human body, one generation at a time. Here's the version most people already know. Humans started in Africa with dark skin. Some groups moved away from the equator, got less sun, and evolved lighter skin over time. Less UV, less pigment. Done. Simple, tidy, the kind of explanation you could fit on a textbook sidebar. Except it's missing almost the entire story. Because that explanation doesn't tell you why light skin evolved independently more than once in populations that never met each other. It doesn't tell you why some of the palest-skinned people on Earth today are descended from ancestors who, genetically speaking, only recently stopped being dark. And it definitely doesn't tell you about the vitamin that's been quietly steering human evolution this entire time. So let's actually get into it. First, you need to understand what skin color is even doing there in the first place. Melanin isn't decoration, it's a shield. Specifically, it's a shield against ultraviolet radiation, and UV radiation is nastier than most people realize. It damages DNA. It causes skin cancer. And critically, it destroys a nutrient your body absolutely cannot function without: folate. Folate is essential for cell division. It's especially essential during pregnancy, where it's directly involved in building a developing embryo's neural tube. Not enough folate during early pregnancy, and you get serious birth defects. Now here's the problem. UV light breaks folate down in the bloodstream. So if you're a human standing under intense equatorial sun with pale, unprotected skin, you are constantly at risk of your own body running short on a nutrient your children need to survive. Dark skin, dense with melanin, blocks enough UV to protect that folate. This is likely one of the reasons early humans in Africa evolved dark skin in the first place. Once we'd already lost most of our body hair and had bare skin directly exposed to the sun. So dark skin is protective. Great. Problem solved forever, right? Except there's a second nutrient in this story, and it wants the exact opposite thing. Think about that for a second, because it's a strange kind of design flaw. Your skin isn't just sitting there passively reflecting sunlight like a car windshield. It's actively running a constant chemical calculation, deciding how much radiation to let through and how much to block, and that calculation has real, physical consequences either way. Too much protection in the wrong environment, and your body quietly starves for something it needs. Too little, and a different, equally important system breaks down. There was never a version of human skin that got to just relax. That nutrient is vitamin D. And here's the twist. Your body doesn't just eat vitamin D, it manufactures it, using UV light hitting your skin as the trigger. Sunlight hits skin, skin produces vitamin D. Vitamin D goes on to do essential work regulating calcium and building strong bones. Not enough vitamin D, especially in childhood, and you get rickets, soft, bowed, deformed bones. Historically, this wasn't a minor inconvenience. It was a slow, disabling condition that could cripple a person for life. So now you can see the trap. Melanin blocks UV to protect folate. But melanin also blocks UV needed to produce vitamin D. Too little melanin near the equator, and UV wrecks your folate. Too much melanin far from the equator, where sunlight is already weak and low angle, and you can't make enough vitamin D at all. Evolution wasn't picking a winner between dark and light. It was constantly rebalancing a trade-off, and the correct answer depended entirely on how much actual sunlight was hitting the ground where you lived. Which brings us to the migration problem. Modern humans began leaving Africa in meaningful numbers somewhere around 70,000 years ago, moving into regions with dramatically weaker sunlight: Europe, Central Asia, the far north. If the simple version of the story were true, you'd expect skin tone to shift gradually and steadily as those populations spread northward, arriving at lighter skin sometime not long after they arrived in these dimmer, colder places. That is not what the genetic evidence shows. Some of the specific gene variants responsible for light skin in modern Europeans appear to have spread and become common surprisingly recently, potentially within roughly the last several thousand years, well after those populations had already been living in Europe for tens of thousands of years. In evolutionary terms, that's not a slow drift. That's closer to a genetic sprint. Something accelerated the process long after people had already settled into low sunlight environments, and researchers still argue over exactly what that accelerant was. One leading idea points at agriculture. Once populations shifted from hunting and gathering, with its varied diet naturally rich in vitamin D from fish and animal fat, toward grain-heavy farming diets, they lost a major dietary source of the vitamin. Suddenly, making it directly from sunlight through the skin mattered enormously more than it used to. The pressure to lighten up may have intensified specifically because of what people started eating, not just where they started living. And here's where the story gets genuinely strange. Light skin didn't evolve once and spread outward like a single invention traveling along trade routes. It evolved multiple times, independently, using different genetic tools in populations that had zero contact with each other. European light skin is heavily influenced by a specific gene variant called SLC24A5. It's a small tweak, a handful of letters changed in one gene, but it has an outsized effect on how much melanin your skin actually produces. East Asian populations also evolved lighter skin, arriving at a broadly similar outcome, but largely through different genetic mutations, involving different genes entirely, including variants tied to genes like OCA2. Two separate populations, thousands of miles apart with no meaningful contact, arrived at a similar surface-level result: lighter pigmentation, by editing completely different parts of their genetic code. Evolution didn't copy-paste a solution. It solved the same environmental problem twice, from scratch, using whatever genetic variation happened to already exist in each population's gene pool. Whatever mutation showed up first and helped got kept, and it may have even happened a third time. Genetic evidence suggests Neanderthals, an entirely separate human lineage living in Ice Age Europe for hundreds of thousands of years before modern humans arrived, carried their own distinct gene variants associated with pale skin and possibly red hair, unrelated to the ones modern humans carry. 3 different lineages, 3 different genetic toolkits, 3 independent experiments, all converging on the same basic answer to the same basic problem. Not enough sunlight, need more vitamin D, need less melanin standing in the way. Now, if this were purely a story about latitude and sunlight, you'd expect one simple rule: closer to the equator, darker skin, no exceptions. But biology loves exceptions, and this one is a genuine curveball. Indigenous Arctic populations like the Inuit live at extremely high latitudes with famously weak sunlight, yet historically retained notably darker skin than you'd predict from latitude alone. Why? Diet. Traditional Arctic diets are extraordinarily rich in vitamin D packed into fatty fish and marine mammal blubber. When you're already getting abundant vitamin D directly from food, the evolutionary pressure to lighten your skin for sun-triggered production drops dramatically. The sunlight rule only fully applies when diet isn't already covering the gap. And within Africa itself, the picture is far more varied than the simple black-to-white narrative suggests. Populations like the San people of southern Africa, living at higher latitudes within the continent than equatorial groups, tend to have notably lighter skin than populations near the equator. Africa actually contains the greatest range of human skin tone diversity found anywhere on the planet, more genetic variation and pigmentation than the rest of the world combined, shaped by the exact same UV and vitamin D pressures playing out locally across a huge range of latitudes, altitudes, and environments. Which means the whole framing in the title of this video is a bit of a trap. Skin color was never a binary switch flipping from one shade to another. It was, and still is, a continuous gradient, constantly fine-tuned generation after generation by wherever people happened to be standing under the sun, what they happened to be eating, and which genetic variants happened to already exist in their ancestors to work with. Quick clarification before we wrap this up, because it trips people up constantly. Everything we've just covered is about evolutionary change across many thousands of years, not the tan you get after a week at the beach. Tanning is a different mechanism entirely. Your existing melanin-producing cells ramping up production temporarily in response to UV exposure, then fading back down once that exposure stops. That's your body making a short-term adjustment within your own lifetime, using genetic machinery you already have. What we've been talking about is something much slower and much deeper. Which version of that machinery your ancestors were born with in the first place, shaped over hundreds of generations, not one summer. So why did ancient humans change skin color? The honest answer isn't one clean cause. It's a running negotiation between two nutrients your body cannot live without, refereed by however much UV radiation happened to be hitting the ground in a given place. Dark skin guards folate. Light skin permits vitamin D. Migration constantly moved the goalposts. Diet occasionally changed the rules of the negotiation entirely. And evolution, working with whatever genetic material each population happened to have on hand, kept finding new ways to strike that balance, sometimes solving the identical problem 2 or 3 separate times. You are still living inside this story right now. Every time you put on sunscreen, you're artificially doing what melanin evolved to do, blocking UV to protect what's underneath. Every time you take a vitamin D supplement in winter, you're compensating for a system that evolved for outdoor life near a specific latitude, not for spending your days indoors under fluorescent light. Your skin tone, whatever it is a living record of a negotiation between the sun and your ancestors' biology that started tens of thousands of years ago and, genetically, hasn't fully finished playing out even now. So next time someone tells you skin color is a simple story about how much sun your ancestors got, you'll know the real version. 2 nutrients pulling in opposite directions, a genetic trade that happened more than once, and a handful of populations that broke the rule entirely because of what was on their dinner plate. That's not a simple gradient. That's one of the most quietly dramatic negotiations in the entire human story, and it's still written directly onto your skin. What about you? Do you know where in the world your ancestors were standing when this whole negotiation was happening? Let me know in the comments. Until then, see you in the next one.